So I wanted to give you guys some advanced tricks in Python. So you guys have gotten pretty much all the basics down. You're doing great. Let's look at some stuff that goes beyond just simple programming. So the first one to start out with, you've actually seen before. We've seen it in some of our functions, such as sorted and print, where we have these arguments that kind of have a default value. And I haven't explained yet what they do or how they work. So I would just wanted to go back and just kind of let you use them. So now I want to go back and explain some of the background, how this is working, and also hopefully to give you the knowledge you need to actually use these in your own functions if you want to. If you want some sort of default behavior in a function that you're creating, you can use these. So you remember this way of controlling sorting, right? So we've got a list, we put it into sorted, and if we want to not follow the default value, which is to go from 1, 2, 3, 4, we can do this reverse. So it's going to go from highest to lowest, 4, 3, 2, 1 instead. And we do that by typing in reverse equals true. And the second argument, so that's an argument in the sorted function, but it actually looks like a variable assignment. It's very similar to when we create a variable and assign it a value. So what's going on here? What is this? So there's two types of function arguments. The Python definition of sorted might look something like this. So it has two arguments. This isn't real, but it's just kind of to give you an example of what it might look like based on what we've seen. So we have the def, we have sorted, then we have a argument for the thing that we're sorting, a list, which will be whatever list it is that the person passes in as a argument. So these are actually our formal parameters right now, right? And then we have a second one, and that is reverse. And in the function definition, we have this assignment that equals false in it. And then we have the rest of the sorting code that actually makes it sort. When someone calls the argument, like we did in the previous slide, so there's the call, sorted, we can pass in my list, the variable name to our list, and then reverse, and we can do not reverse false, we can do reverse true. And that's going to make it not be, actually, it's kind of backwards here. It's going to make it be reverse, right? It's going to make it not be false reverse. It's going to change the value. So this is a great illustration of the two types of Python arguments that we can have. Python functions can be called with what's called a positional argument, which is the standard one, which you've learned to use. That's what we've seen in most of our functions. There's a second one, a second kind of argument that's called the keyword argument. And this is the one that looks like a variable assignment. These are optional. You don't have to have them into a function. And when you call a function, you don't have to call these ones, right? They have a default value. Reverse is always going to be false unless you change it to true. So these things are equal, and in that, or following that equal or assignment operator is going to be that default value. So by default, it will, reverse sorting will be false. So you can create a function with a default behavior by giving a keyword argument and then assigning it the default value. And that could be a Boolean value, it could be a list, it could be a number, whatever it is that works for your function. The rule here for the syntax is that when you're writing the definition, all the positional arguments must come first, and then all the keyword arguments. So in the function definition, first put all your positional arguments, and then your keyword arguments must be last. That's in the definition. When you call the function, it's very similar. The positional argument or arguments must come first. However, the order of the keyword arguments, it doesn't matter. It doesn't matter what order you put the keyword arguments in, as long as they come after the positional arguments. So that makes sense, right? Thus the name, positional arguments. They need to preserve the position in which they exist in the function definition. So here's an example of multiple keyword arguments. You're not limited to one, you can have more. So sorted, as we know, actually has more. So let's say we're sorting a list of 2 tuples. And this is something you've seen. Sorted, pass it the positional argument, which is the thing we want to sort. And then we have 2 keyword arguments. We have the key, which is going to tell the sorted what to look at when it's comparing and sorting. So there's our little anonymous function that's lambda x, and that's saying looking at the one element, the second element in the tuple to compare and decide how to order those two. And then the second keyword argument is reverse equals true. And it's gonna work. It's gonna give us our list of sorted tuples by alphabetical order, by the words, which is the second element. We can do this same thing. We can call sorted again with the same list, the same two arguments, but note that we've switched the order of our keyword arguments. So now reverse is true and the keyword argument is second. This is not going to have any effects on the results. Those keyword arguments can be in any order as long as they're following that positional argument. It's pretty cool, and it makes sense too, because if you think about it, when we call these keyword arguments, we're specifying which argument it is by using the name reverse or key. So Python can keep track of which argument it is because they have names. What you can't do is put the keyword arguments before the positional argument. So we can't put reverse and key or either one or the other before my list. If we do this, Python's going to throw us this actually very convenient little syntax error because it specifically tells us positional argument follows keyword argument. That's the problem. You can't have that positional argument following the keyword argument. You're violating syntax. But as long as the positional argument's first, keyword arguments can go in any order. So this is something we've seen and we've worked with. Hopefully that clarifies and you can now use that in defining your functions. Here's something we haven't seen, which is using asterisks in arguments. So let's walk through an example. Let's say we have a function definition, add 3. It has three formal parameters. So it's going to take 3 arguments, and it simply returns the addition of those 3 arguments. So obviously we're going to need integers or floats. So if we use these 3 integers and we call our function with these 3 integers, we're going to get back the result 6. 1 plus 2 plus 3 is 6, right? Well, if we try this, if we try add 3 and then feed it this list of the same 3 numbers, we're going to get an error, right? And it tells us it's a type error. It says add 3 is missing 2 required positional arguments B and C. So it looks at it and it sees a list as one element. And it says, okay, I'm going to assign that to my first formal parameter, which is A, and then it looks and sees, wait a second, I need the last 2 and I'm missing them. So it's not going to work because Python only sees the list as one element. So you're thinking, okay, somehow we've got to get those 3 elements out of the list, maybe by indexing and pass them into the function one by one. However, we can do this. We can add an asterisk in front of that list. So we can, instead of indexing in and getting each of the elements, let's just pass it that list, and in front of the list, put an asterisk. If we do that, we're going to get back 6, which is exactly what we would get if we passed in each of those numbers as an argument. So why is that working? What's the difference here? So that little asterisk, which comes before the argument, before the list, it has a function in Python. It's a little advanced trick that it's going to convert that list into each of the individual elements and feed them into add 3 as separate arguments. So it's kind of looking into the list and passing the elements in the list as the arguments in those required positions to the function. And you'll see this used a lot in Python. You can think of some, it's very convenient. You don't have to index in or write that extra code to index in, or maybe write a loop where you feed the separate items. You can just have a list of what you've gotten, maybe stored somewhere, and just pass it in and put the asterisk to tell Python to convert those elements in the list to the arguments that you need. And this is called unpacking. So you can unpack a list into separate arguments. It's a very convenient little trick. So keep in mind that little trick with the asterisk that unpacks the things in the list and feeds them individually. And let's take a close look at zip, the zip function that we learned in a previous lecture. So we saw this, right? So we can feed zip two tuples. Each of those tuples is an argument in zip. And then we cast it as a list because remember, zip returns an iterable, it doesn't return a list. And so to see it as a list and to use it as a list, we need to cast it as a list, and our result is going to be what? So think about this. do a little review. Remember from the previous video, what's going to be the output of this line of code? So the output of zip, what zip does is it takes these two iterables, these two tuples, and it matches the ith element in the first iterable with the ith element in the second iterable and the ith. So I is whatever element we're looking at this moment. So index element 0 is going to be matched with index element 0, 1 with 1, etc. So what we're going to get is a list of two tuples where 1 has been matched with A, it's kind of zip them together, and 2 with B. What if we take the elements in that list that we just zipped, so the 1A tuple and the 2B tuple, and feed it to the same function, zip and then cast to a list? What's going to be the output of this? Well, Python's going to do the same thing, right? It's going to take the two elements, it's going to look at the first one and match it with the first one in the second list, and the second element in this first tuple here and match it with the second one, right? And what's going to end up is we're actually going to get the same thing that we fed into the first line of code, right? That 1, 2, and the AB. Well, it's almost the same thing. What we fed into zip on the first line is multiple elements. So two tuples, two tuples with two elements in them. This now, what we have is a list of tuples. So to use this, we needed to cast it to a list. And to see it, we had to cast it as a list. So now it's one element. So what happens? So we've gotten from 1A and 2B to 1, 2, and AB. What happens if we pass this list, which is not multiple elements, but one thing, and pass it to this same function, zip, then cast to a list, but add the asterisk to it? What do you think the output of that is going to be? Well, if you remember from the previous slide, asterisk is going to take each of the individual elements in the list and pass them as arguments to our function. So it's going to take the first tuple and pass it as the first argument, and the second tuple, the 2b, and pass it as a second argument, and then zip's going to work. And what we're going to get is the thing we started out with, right? So what's the logic here? We started out with two tuples, 1, 2, and AB. We zipped them and cast it to a list. That's what we got in the first one. And in the second line, we took each of those tuples out of that list and passed it to get kind of the opposite of what we started with. That's one way of doing it. On the third line, we simply, instead of taking out the elements, we simply passed the list, put an asterisk in front, and we got a list that was now actually, I guess you could call unzipped, right? We got the original of what we wanted now in a list. And that's actually why Python doesn't have a separate unzip function. We only have a zip function, because this nice little trick here with the zip and with the asterisk is equivalent to an unzip function. So if you zip something and pair them up this way, and then you realize, whoa, I need to undo that, or I need to, I don't know, redo it, then you just simply take the output of that zip, pass it to zip again, and use the asterisk. So that's a nice little trick. There's some other things you can do with zip which are pretty cool. So one thing to know is that zip doesn't just work with lists. It actually works with any iterable, including strings, right? So strings are iterables. They're actually kind of list of characters. So we can take two strings, ABC and DFG, pass it to zip and cast it as a list. And what we're going to get is a list of 3 tuples, each with 2 elements in them. A is going to be matched with D, B is going to be matched with E, C is going to be matched with F, and G, because it's extra, is not going to even appear in the list. So zip ignores. If you have 2 iterables of differing lengths, it's only going to pair up the shortest list, whatever the shortest is. In this case, we have 3 letters being matched with 4 letters. It's going to take the 3-letter one, and that's all you're going to get. You're going to get a list of 3 tuples. So G is just left out. Whatever's extra is just going to be left off. We can take a string, just one single string, let's say the dog, And we can do this little trick. We can take the string itself, the dog, as the first argument to zip. And then we can take my string and use the slicing notation, 1 colon. And what's that going to get us? So 1 colon is going to start with the 1th element, and everything else is going to go to the end. With that, when there's no number at the end of the slicing notation, it's just going to go to the end and get everything. So what we're doing is we're going to zip the full string with the string minus the first letter. So what's going to happen here? What's it going to look like? Well, if we match up the full string with the string minus the first letter, it's going to match up the first letter in the full string with the first letter in the second argument there. So the first letter in the full string is T, and the first letter in the second string that we've passed, or the second argument that we passed, is H. It's going to pair those up, and then it's going to pair up the next two and the next two. So what we have here is actually a list of all the 2-letter sequences found in a text. TH, then HE, H, and then the end of the word. We're including white space here. This is pretty cool. It's a pretty cool trick. You can use this in a lot of different things. It's kind of fun just to do it, but it actually has pretty far-reaching implications. Why is it cool? Well, this idea of pairing up 2 or even 3 or 4-letter sequences of characters in a text, which you can think about how to do that with zip, it's not too difficult, is a basis for a lot of natural language processing and tests. So, for example, if you go to Google and you go on a page that's in German, Google's going to ask you, do you want, if you have it set up, it's going to ask you, do you want this to be translated from German into English? So how does it know, if it's never been to that page before, that it's German? Is it indexed somewhere? No, that would be a lot of problem to try to index every single web page on the internet. I don't know exactly how it's doing it now, but the simplest way to identify a language is actually to get these 2-letter sequences like this, which you can very simply do in 1 line of Python code, and then count the frequencies of those pairs. So if you get 2 languages that use the same alphabet, such as English and German, and you do this little zip thing and get the 2-letter sequences, and then you count the frequencies of those sequences, you're going to have very different numbers. You're going to have different pairs, for one thing, because letters are going to be in different orders in the different languages. And then you're going to have, even with the same pairs, you're going to have different statistical frequencies of these texts. And so there's actually a very simple way for the computer to identify what the language is that it's looking at. There's some other cool things related to that. So if we take that idea of pairing up letter sequences, we can do something else that's cool. So let's walk through this code right here. This is going to look very familiar to you from homework 4 and from lab 11 and 12. So the first line, we're opening up a file, which is this 1200 WSJ. By the way, WSJ stands for Wall Street Journal. That's where this text is from. And the slashes and the dots before that is actually just telling Python where to find this file. So it's a little shorthand that you can use sometimes. So this ... is saying, look at the next folder up. Start in this folder and look in the next folder up, and then you're going to find that file in the next folder up. So you can actually tell Python where to find the text if it isn't in the folder where the code is. The next line of code is reading that line of text, or reading the first line of text, which we know is 1 line of text. That's all there is in this file. Then we have zips. Zip is doing what we saw on the previous slide. It's taking that line of text and it's zipping it with the line of text minus the first letter. So it's going to get us a list of 2-letter sequences, right? Then we're declaring an empty dictionary, and we're iterating over zips. We're iterating over that list of 2-letter sequences, and for the letter pairs in zip, we're adding that to our dictionary. So the pair is being added, so that tuple is actually being the key in our dictionary. And here we're using the .get, and this is a 1-line way of avoiding the key error. So, we need to make sure before we call the key that it's in the dictionary. You can do that with an if-else statement, or you can use the get function, which is saying, okay, get that key, and if the key is not there, then add the key and give it the value of 0. So it's gonna initialize with the value of 0, and then it's going to add 1. So every time it's gonna add 1. So every time it sees it, if it's not there, it will add it, give it a value of 0, and then add 1 to that for the first time it's seen it. The next time it will get it, since it's already there, it won't add a 0 as its value, it will simply add 1 to whatever is there. So what we're doing is counting the frequency of the 2-letter pairs in our text. And then we're going to sort them. So we're going to sort using dot items, and our key here is saying sort it by the frequency, the second item, which is our value, right? When we have the dot items, the second element in the tuples that it's going to look at is the number, so that's the frequency. So we're sorting by frequency, reverse true, meaning we're going to start with the most frequent first. And then we're using, so right, sorted is going to return a list. It's going to return a sorted list. And so we then can add onto that. Once it returns that sorted list, we can use this slice notation to get the first 10 elements. So what we're going to get is the first, the 10 most frequent, or that is what we should get. Let's see. So that's the code. Let's kind of walk through what's happening here. So the first line of code is going to start out like this. If you've looked at it, which hopefully you've eyeballed it, you've seen that that file starts out like this. When we zip the text with the text minus the first letter, we're going to get these 2-letter sequences. PI is the first 2-letter sequence. The next 2-letter sequence is IE, then ER, RE, RR, and then RE, etc. So that's what zip's value is if we printed it out. Then we're going to count. We're going to count the frequencies of those 2-letter pairs. And this is what, once we finish, this is what count would look like. It's a random ordering. PI occurs 7 times. IE occurs 308 times. If you'll notice, the most frequent one here is E at the end of a word. So E followed by a space, which occurs 3,480 times. Many more times than PI, interestingly enough. But if we want to know, so this is just kind of a random, it's a random sorting. If we want to know what the most frequent and whether maybe E at the end of a word is among the most frequent, we're going to call our second line there, which is going to sort and then get the top 10. And this is what's going to get returned from the sorted call. And here we can see that actually E followed by a space, so E at the end of the word is actually the most frequent 2-letter sequence in that text. So if it's, you know, an example of an average English text, we could say maybe that E at the end of the word is the most frequent maybe we shouldn't say 2-letter, 2-character sequence in English text. And actually it's followed by S at the end of the word, and then T at the beginning of a word, A at the beginning of a word, D at the end of a word. Actually, we go through 1, 2, 3, 4, 5, 6 before we get to a 2-letter sequence that is among the top 10. And if we did this, of course, if we took off the white space or ignored the white space, and when we zipped, we would get very different counts. And if we did this with a different language, French or German, that use the same characters, the same alphabet, we would get different results indeed. So that's a cool little thing, and you can use this. It's a fun little exercise. If you master this, you can take this little code here and go on to work in machine learning. So if you take the machine learning and linguistics class, you can actually they'll start with this basic counting here and the zipping, and then you do a little bit more math, and you can do something like automatically determine whether hotel reviews, thousands of hotel reviews that's been harvested from the web, whether they're positive or negative or neutral in regards to the hotel. So this is a fun little exercise that's helpful for later natural language processing. It also is helpful for you because it's something you will see in the take-home final. All right, last slide here. I'm just going to give you 3 more very common functions in Python that are very useful. And These are actually ones I haven't told you exist before. I think some of the, well, I know some of these you've actually programmed yourself throughout this class, but now that you know how they work and you know how to program them, you can just use these built-in functions in Python. So the first one is sum, and sum simply takes a list and adds everything together. So if you feed it a list of 1, 2, 3, 4, it's going to add 1 plus 2 plus 3 plus 4 and give you back 10. So it's a good way to, it's an easy way to add together some numbers. Max takes in an iterable, and it's going to find the maximum element in an iterable. So if you feed it a list of 1, 2, 3, 4, it's going to return the maximum element, which is, of course, 4. That's the highest number. It works with any iterable. So you can see on the next line, it works with dictionaries too. And as you can probably guess, based on what you know about dictionaries, it's going to get the max of the keys. And so 3 in this particular dictionary is the highest key. It's going to return 3. It's going to return the key. It's going to find the max key and return the max key. Now, max has a keyword argument called key, much like sorted. If you feed it mydictionary.get, get's going to go and find the value of the key as it's looking through the keys. It's going to look at the value. So if you do the dictionary mydict and then the keyword argument key and feed it mydict.get, you will get the max. It will find the max of the values, but it's going to return the associated key. So in this case, it's going to look at A, B, and C and find the max of the values, which happens to be C, which we could guess. And this kind of tells us that it's not just looking at integers, it can look at characters. If it does so, it's looking at the underlying ASCII numeric value of that character. So C is after A and B in the ASCII chart. So it's going to return the key of C, which is 2. The third function here, which is very useful, is min. And min is going to get the minimum element in an iterable. So it's the symmetric and otherwise works the exact same. So these are some advanced tricks. I've done a lot. It's a bit of a fire hose here, but these are all very useful, well worth spending time to get to know. And as you work with letters and work with text and numbers, you'll find yourself using these very often.